everyone, it's me again. I'm Lena and I'm from the Healthcare Landscape Group. In this video, I'm going to be talking about my 3rd edition A, which is about drug calculation practice. Basically, in this video, I'm going to cover 3 main problems that Mrs. Pratt sent out in our weekly DE3B problems. And for this, we will have 3 main problems, 3 types. Oral dose, the intravenous 4 dose, the subcutaneous dose. And yeah, those are the 3 main problems that we're going to do in this video. We're going to practice over that. And we're going to be applying the 3 main formulas that I have talked about in my third DA, which is the daily dose, the single dose, and the dose volume. We're going to apply that in these 3 problems today. So without further ado, let's get started on our first problem, the oral dose. Let me read the problem. Keflex 750 milligrams per dose every 12 hours for 1 week is ordered by Dr. Kennedy. The Pool Bay Pharmacy stocks 150 milligram tablets. How many tablets should be administered per dose and for 1 week? Now, there are 2 main questions, which is how many tablets should be administered per dose and how many tablets should be administered for 1 week. So we're going to have 2 different problems to solve. Let's start first with the first one, the tablets per dose. Now, let's look at the formula. What are they asking? Well, they are asking for how much could be administered per dose. What information do we have already? Well, we have 750 milligrams of Keflex for every 12 hours. And that is for 1 week, is ordered by Dr. Kennedy. And the pharmacy stocks 150 tablets. How can we find this? Well, to find the tablets per dose, the single dose, we will take the prescribed dose and then we will divide that by the tablet strength. In this case, the tablet strength is 700. The tablet strength is about 150 milligram tablets. So that is the tablet strength. How do we find the 5 tablets per dose? Well, firstly, we will need to get the prescribed dose, which is 750 milligrams. And then divided that by 150, and let's do this problem together. We will take divided by, and we know that if we take 15 times 5, this will equal 75. Therefore, our answer is 5. And there will be 5 tablets per dose. So that means that we will take 5 tablets at a time. Now, with that information in hand, how can we do the second problem? Well, the second problem is related to the first. Just we need to do the weeks. How can we know the doses per week? Well, we will take the doses per day, 2 doses per day, and then we will multiply this by 7 days. Do you know why? Well, if we take 2 times 7, we will have 14 doses. And if we take 14 doses times 5 tablets, we will get 70 tablets per week. And that would be a reasonable answer. Or we can think about how many hours are there in a week, and then we can multiply that to make 70 tablets. And in this case, 165, I remember that there are about 165 hours in a week, so we can multiply that by multiply that to make 70 tablets. So yeah, that is for the oral dose. There will be 5 tablets per dose. There will be 5 tablets per dose. That's for the number of doses needs to be taken. And then there are 70 tablets per week, which will be the number of tablets given to the patient in a week. That is for the first problem. The second problem is the intravenous 4 dose, and I'll read the problem. In order for digoxin 0.5 milligrams for daily is placed by Dr. Lena. Digoxin 0.25 milligrams per milliliter is available from Boots Pharmacy. How many milliliters will you need to administer a 0.5 milligram dose? Well, for this problem, it says that how many milliliters will you need to administer a 0.5 milligram dose, and look at what they have. Look at the information that they have. It's 0.25 milligrams per milliliter, so we know that's a concentration, and we must find the volume because the concentration is in liquid form, and liquid form must be a volume. And the volume is in milliliters for this, and I do have the dose volume for the milliliters per dose. If you recall, we have the single dose, which is milligrams per dose, divided by the concentration of the drug, and yeah, this is exactly how we have on the board. And in this case, we will put this formula into implementation. We will implement this, and yeah, we will have the dose per milligram, dose in milligrams, which is 0.5 milligrams, and the concentration is 0.25 milligrams per milligram, and that will lead us that we will divide by to make 0.5 milligram per dose, and that will mean that our answer is 0.5 milligram dose, a 0.5 milligram dose. That, yeah. Then we will have the last problem, the subcutaneous dose. Now for the subcutaneous dose, our problem is heparin 7,500 units of subcutaneous every 12 hours is ordered by Dr. G. Edwards. The Poole Hospital Pharmacy provides a heparin vial with a concentration of 5,000 units per milliliter. How many milliliters will you need to administer for 7,500 units? Well, for this problem, we have one question to answer. Firstly, how many milliliters will you need to administer for 7,500 units? What do we already know? Well, we already know that heparin, we will need to administer 7,500 units of subcutaneous every 12 hours. And for this, we will need to find the volume because it says so. It says 5,000 units per milliliter, and milliliter is in volume. So we have the formula, which is dose for the units in units. This is similar to the formula that we have in the second problem. And then divided by the concentration, which is the units per milliliter. Now this is milligram per milliliter, but this is units per milliliter. That will depend on each kind of problem, depending on the units that they give us. And this will be implemented into 7,500 units divided by 5,000 units per milliliter, which will give us 1.5 milliliters. And 1.5 milliliters will be administered to 7,500 units. And yeah, those are the problems that we have in our third DEB this week. I hope that you learned something new or reviewed something that you have learned from my third DEA or from other sources on the internet. And thank you for your time and attention. I hope that you have a great day, and goodbye. See you soon.